Alright, so today what we're going to do is we're going to start one variable statistics. We've been looking at two variables on a scatter plot, but we're going to go back to one variable. Now a lot of this will seem familiar, but it's important to get the details down so we're all using the same vocabulary. We're first going to talk about the representations. We're going to focus on three ways to represent data. The first is called a dot plot. This is a graphical display of data where each dot is one data point. So over here on our example, we can see that there are two values that have a value of 1. And then there are 4 data values that have a value of 2, and so on and so on. This is a great way for small data sets if you want to see each individual point. The next is a histogram. This is similar to a dot plot, but this is a graphical display where data is grouped into intervals. So you can see for our example here that there is a group of 60 to 65 that has 3 values, and a group of 65 to 70 that also has 3 values. And then the group from 70 to 75 has 8 values. So this is a great way to look at bigger data sets in groups. The last is called a box plot or box and whisker plot. This is a graphical display of data using the 5-number summary. The 5-number summary includes the lowest value, which is also called the minimum, quartile 1, or lower quartile, quartile 2, which is also the median, quartile 3, which is the upper quartile, and the highest value, which is the maximum. The important thing to know about a box and whisker plot is that it divides our data into sets of 25%. So 25% of the data is between the lowest value and Q1. 25% of the data is between Q1 and Q2. 25% of the data is between Q2 and Q3. And 25% of the data is between Q3 and Q4. On this box and whisker plot, you can see that the biggest spread of the data is between Q2 and Q3. The same number of data points are in each of these boxes, but this one is more spread out. Alright, now we're going to take a look at ways to represent center and spread. The first is the mean. This is the average or the balance point of a set of data. We tend to think of the word average and mean as the same thing, and they are, but we want to remember that this is the place where if you gather all the data and that you distribute it evenly, then this is the mean. In order to find it, we're going to add the data and divide by the number of data points. The next one is the median. It's also called Q2. This is the middle of a set of data when in order. A lot of people think about crossing out from the each side till you get to the middle, and that's a method to use this. To find it, make sure that you put the data in order first, then find the middle. If 2 values are in the middle, then you're going to average those 2 values. So you're going to add them and divide by 2. The next value is Q1 or quartile 1, also called the lower quartile. This is the middle of the lower half of the data. So once you get the data in order, you find the median, then you just look at the lower half and find its middle. Alright, the next thing is quartile 3. This is the middle of the upper half of the data. Same way, you find the middle of the upper half of the data. The interquartile range you find by taking Q3 minus Q1. This lets you know how spread out the middle 50% of the data is. A couple of more definitions. The minimum or the lower extreme is the lowest or the smallest data point. So once you have them in order, it's easy to find. Just find the smallest number. The maximum or the upper extreme is the largest or the highest data point. So again, when you have it in order, find the largest value. The range we find by taking the maximum minus the minimum. This represents how spread out the data points are. If you have a small range, they're pretty close together. If you have a large range, it's pretty spread out. An outlier. This is a value that is much smaller or larger than most of the data. A lot of times we think we know what the outlier is, but there's a formula to find out. we use Q1 plus 1.5 times the IQR to find what's called the lower fence. We find Q3 minus 1.5 to equal the upper fence. When you calculate those two values, if the data points are between those two values, then it is not an outlier. Lastly, we have the mean absolute deviation. This is the mean of the distance of each value from the mean, and we'll talk more about this in depth in a later lesson.